So here we're going to make a time plot of the mean temperature in the state of New Jersey in intervals of 5 years. Our x-axis is going to be the year. And I'll put a break in the graph because I'm not starting at 0. And we're starting at 1895. And I will write vertically so as to be able to write all the digits out there. Okay, fortunately I had enough boxes to be able to incorporate all those. Sometimes you have to make modifications depending on how many tick marks you're given. And the y-axis obviously is going to be the other variable here, mean temperature. And it's in degrees Fahrenheit. And the title of this chart could be New Jersey annual mean temperatures from 1895 to 2010. Yes, sir. So what this means is an average of, I believe, all of the months of that year. So that's why I'm using this word. I understand that it could be confusing because I'm not going in steps of 1 year, but I'm using the word annual because it's a year-long mean. Okay? If it's confusing, then I would say you could replace it with year-long. But I believe they mean the same thing. Let's look at the range of our data. Our lowest temp is what? 49.7. That was the coldest year, 1940. And our highest temp? 54.9, 2010. That was our warmest year. And let's see how many boxes we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, highest temp minus lowest temp divided by 25. So I can go in steps of 0.2. Okay. Actually, it needs to be a little bit more than that. So maybe 0.25. Okay. Yes, I could. So I could start at 49.7, but maybe just to make the math easier, I'll start at 49.5. Again, another break. And I'm going in quarter degree increments. 49.75, 50. And maybe just to save time here, I won't write every quarter increment. So 1, 2, 3, 4, so there should be 51 degrees. 1, 2, 3, 4, 52 degrees. 1, 2, 3, 4, 53 degrees. 1, 2, 3, 4, 54 degrees. 1, 2, 3, 4, 55 degrees. Okay, so that's an option as well. And then it's just plotting the points. So in 1895, our average temp in the state was 50.9 degrees. In 1900, it jumped up to 53.2. 1905, back down to 50.6. 1910, 51.3. 1915, 51.9. 1920, 50.6. 1925, 51.7. 1930, 52.2. 1935, 51.3. 1940, 49.7. 1945, 52.3. 1950, 52. 1955, 52.9. 1960, 51.9. 1965, 51.8. 1970, 52.1. 1975, 53.3. 1980, 52. 1985, 53.1. 1990, 54.7. That was a warm year. 54.5. 1995, 52.9. 2000, 52.5. 2005, 53.9. And 2010, 54.9. Okay, so we're going to connect the dots because this is a time series plot. We're interested in the change over time, and it's hard to discern the change over time if we don't connect the dots. It just looks like a scatter plot right now. Okay, and maybe I'll use a straight edge. By doing this, one could say an assumption may be being made, and that is between the points you have this straight line. And I want you to be aware that that's not necessarily true. There could be some erratic behavior going on between the points, but we don't know because we don't have the data here, at least. But as you do this, start to draw some conclusions about what's happening to mean temps in New Jersey over time, at least in these 5-year increments. And some of the things that you'll want to think about are things that you would think about with a histogram in terms of average, spread. It's harder to discern modes with a time plot. Okay. Voila, time plot. Pretty straightforward. Any questions, though? Okay. It's going to be okay, Ethan, I promise. Now, let's write down things that we notice. Okay. So I'll call on random people. Okay. Matt, tell me something that you noticed, please. Yeah, with the time plot, it's easy to determine the minimum and the maximum. Okay, 1940 was the coldest year, whereas 2010 was the warmest year. Good, tell me more. It's not a steady increase. I agree. Okay? For example, we go up quite a bit from 1895 to 1900, and then we come back down more than we went up. Okay? And then up and down. Up a little bit more, but back down again. However, Matt, what's the overall trend here? Yeah, overall the temperatures are going up. Okay, if you think of a trend line here, it would look like that. Good. Other things that you can discern are any oscillations. So, like for example, you have up, down, up, and then maybe a more general or broad scoped oscillation here. Think sinusoid. But yeah, you can also see where it's flat. But be careful. There's something called the danger of extrapolation. Do you know what that means? Are you okay, Unwan? Just checking. I'm responsible for the well-being of my students. So, extra means what? More. Yeah, or outside. Okay. And pole refers to a point. So outside point, extrapolate. In this context, it would mean predicting temperatures in the future. And it's just like predicting stock prices in the future. You cannot guarantee future performance based on past results. And we're not guaranteed here that the trend will continue in the positive direction. But it looks like it's going to. Okay? So you can say, well, we don't know that the temperatures are going to continue to increase. But you don't know anything. Life is about working with probabilities, I would say. Risks. So you look at the data. You think about what are the costs of doing things and what are the costs of not doing things. And then you make a wise decision based on that. Okay? So the time series plot, it's nice. Shows you how the variable is changing over time. The histogram can't do that unless the histogram was animated, I guess. So on the back here, we're going to do a histogram. But actually, before I do that, let me show you how to do the time plot on the calculator. Okay. How did I get to this screen? Stat, very good. Okay, and then number 1, edit. I have my data from yesterday in there, and because I want to use that for another class, I'm just going to move that to L3. If you want to clear it, you can.
How do you clear an L3?
You clear an entire list by going to the very top such that the heading is highlighted, and you press clear and then enter. If you want to delete a single element from a list, then you move your cursor or the highlighting over that value you want to delete, and no surprise, you hit the del key. And that will delete an element. I wouldn't delete an entire list, because then you have to get it back. Okay? Alright, so I think the calculator will be able to handle the year information. If not, no big loss. And then we'll put the variable in L2. Ethan, you may want to look on with someone. I'm concerned about you not being able to follow along as closely, but it's up to you.
Yeah, I went solo on my calculator and I haven't got it back yet.
Okay. Just because we're going to more and more frequently be using the calculator, and if you're not fluent with it, I think you might be at a disadvantage. Okay, so hopefully I typed those in correctly. And let's do a time plot. So let's go to where? Second. Y equals, very good. Now what? 1. Make sure it's on. We're going to use the second type. And our X list should be L1. Those are our years. And our Y list is L2. Those are the temps. You can choose whatever mark you want. No option for Matthew here, just mark. And then what? Graph.
How did you do as far as the
How did I do what exactly?
How did you get to that screen?
Second Y equals. Okay, graph did not work. Fail. Zoom stat. Let's try that. Bam! A time plot. And like with the histogram, you can press trace. Okay? Now, to the back. The time plot can't show you modes, and sometimes it's hard to discern things like mean and median from it. So we'll use a histogram, which shows a distribution, how the data is distributed, or like spread out. I guess you could think of it that way. We have been dictated a bin size, 1/2 degree, and that we start from 49.5 degrees. Okay? Since I showed you this, tell me, how do I make a histogram on the calculator? Yes?
You go to second Y equals.
Second Y equals. Next,
Plot 1.
plot 1.
Then you go to the histogram.
Go to the histogram.
And then don't you need your Y list?
Well, there is no Y list. But I think I know what you mean. So try again with different words.
Don't you need your L1 and L2?
What am I trying to graph here?
Global warming. Well, not actually global warming, but the this
Okay, what's that you're pointing to?
year and mean temperature.
Which one? Year or mean temperature?
Mean temperature.
Yeah. And what list is that in right now?
2.
2. Does anyone know how to pick L2?
Second 2.
Nice. Second 2. Okay, see it changed to L2. We'll use this frequency list option later. And then zoom stat. I always do zoom stat first, and then I can change the window later. Okay, there's a histogram of the temps. Now we can see the most frequent temp is between 51.4 and just under 52.3. Okay, we can see a skew to the right here. Even with that skew to the right, I still expect that the median is in between these two numbers here. The mean I expect to be higher than the median because of the skew to the right. And we can tell the range, somewhere between 49.7 to 55.8. Unimodal. But this is not using the parameters that I dictated. So what do I need to do?
Change the distance.
Yeah, how do I do it? Window. X-min should be 49.5. X-max. Let's leave it alone for now. We can tweak it later. X-scale. 0.5. Y-min. Leave it. Y-max. Leave it. Y-scale. Leave it. X-res. Who cares? Let's hit graph. Don't do zoom 9 again because it will reset your parameters. Bam. And then hit trace. Okay. So now you can see it's correct. You are allowed a calculator on my assessments. You are allowed a calculator on the AP exam. I strongly, and the College Board strongly recommends you take maximum advantage of the calculator. So if you're asked to make a histogram on the piece of paper, you don't have to, but I encourage you to at least consider doing it on the calculator and then just transferring it. Okay? And, I think I've called in enough people for this particular topic, so I'll just say it. It looks unimodal, with the mode being between 52 and 52.5. It's the most common temperature. However, you might have this secondary mode here, but that might just be due to chance. It's a little on the uniform side, or if you want to use a technical term, it's platykurtic. It's a little flat. So it's not like there's one temp that most of the years are tending towards, like the vast majority of the years are tending towards. We do have some gaps here that I think are worth mentioning. We have 1 year here that's a little bit removed from the rest of the pack. So that might be considered slightly an outlier. And then these 2 years over here, these two very warm years, relatively speaking, we would point those out as well. Center looks like between 52 and 52.5, where the mode is, coincidentally here. And range, somewhere between 49.5 to maybe 55. Or like 6.5 degrees or so. But I can't tell that with certainty because I don't know exactly what's in this bin unless I look at the data. Okay? Good. Any questions on making a time plot, either by hand or with the calculator? Making a histogram, either by hand or with the calculator? Commenting on features of a time plot or features of a histogram? All essential skills. Okay?